Boys and girls, this is Mr. Manise here again with another super awesome video, and in this video I'm going to walk you guys through the quiz review problems for chapter 3 with our triangle congruence postulates. And as my disclaimer as always, do not come to this video and just watch me work the problems and copy down the answers. I need you guys to work these on your own and then come to the video and iron out any misunderstandings that you may have. So keeping the tradition with my Clemson opening here, let you guys take a look at this. This is just a plastic football, Clemson football helmet. But as you can see here on the top, it is signed Go Tigers by Tommy Bowden, who is the brother of the legendary Bobby Bowden, Florida State coach all those years. And Tommy Bowden was Clemson's coach for a while in the late 90s and for most of the 2000s. So pretty cool autograph Clemson helmet. All right, so let's go ahead and jump in. So I thought we'd start with the 16 book problems on page 192. And the first one that we have, number 1, is we have ourselves a congruence statement. RSTUV is congruent to KLMNO. Okay, so they are asking us, and let me zoom in just a little bit here. So we've got some kind of pentagon or five-sided shape, and number 1 is asking for what is congruent to TS. And all you have to do, guys, is just match it up with the congruent statement. TS or ST is in the second and third position, so that's going to match up with LM, which is also in the second and third position. So TS is going to be congruent to LM. Number 2, they're asking angle N. Angle N is in the fourth slot, so that's going to match up with the U, angle U. Number 3, LM. LM is the same thing. LM is in the second, third slot, so that's going to match up with ST. Number 4, we have VU TSR. Okay, so if we go in that order, we're going VU TSR. We're just going backwards. So here I'm going to have to go ONMLK. ONMLK. All right, number 5, we have a congruent statement. We have another one. We have WXYZ is congruent to PQRS. Okay, and then we have a couple of diagrams here. We have what looks like, and remember we can't go based on what it looks like. It looks like we have an upside down trapezoid, WZXY, and we have 80 degrees here, 145 degrees here. We have a length of 8.6 and a length of 3 centimeters, feet, doesn't matter. And we have the other trapezoid looking quadrilateral over here, RQPS, 35 degrees, 100 degrees, a length of 10, and a length of 5. Okay, and they just want us to match up some stuff. So number 5, it says, what is the measure of angle P? What is the numeric value? Okay, well, where does P match up? Again, you don't need to even look at the figures. Just look at the congruent statement. P is in the first slot. That's going to match up with W in the first slot. So if W is 80, P has to be 80. Okay, so that's 80 degrees. That's easy. Number 6, they're asking for QR. What is the length of QR? Okay, QR is in the second and third spot, so that's going to match up with XY. XY has a length of 3, so QR has a length of 3. And remember, it doesn't matter whether I say QR or RQ. The order of naming a line doesn't matter, or naming an angle if you're using the 3-letter method. Order doesn't matter. All right, number 7, they're asking for the length of WX. Okay, WX is in the first and second slot. That's going to match it with PQ. And QP or PQ is 5. So XW or WX is also going to be 5. Number 8, what is the measure of angle Z? So Z is in the fourth position, S is in the fourth position. So if S is 35, then Z has to be 35. 35 degrees. Number 9, what is the measure of angle X? X is in the second position, Q is in the second position. So Q is 100, X has to be 100. 100 degrees. And number 10, what is the measure of angle R? R is in the third position, Y is in the third position. Y is 145, so R has to be 145. 145 degrees. Oops, sorry, y'all couldn't see that. Yeah, Z is 35, 9 is 100, and 10 is 145. Just matching them up with the congruent statement. Okay, so that's pretty easy. Let's flip on over section 3.2 and 3.3 with the triangle congruence postulates. Number 11 is asking for included. Okay, so let me come out here to the side and go over what that means again. Included, the word included just means in the middle. Okay, so if I have a triangle A, B, C, and I give you a tick here and a double tick here, if I ask you for the included angle, that means which of the four corners, three, which of the three angles, the three corners, is in between these two sets of ticks. And you say, okay, well, it's angle B. Okay, so angle B is sandwiched in between the two sets of ticks. So B would be included. What if I put a double arc here and a triple arc here, and I ask you which side is included between angles A and C? Well, the side that's included would be this side here, this set of triple ticks. So in that case, it would be side AC. Okay, so that's just what included means. Number 11 says in triangle HDF. Okay, HFD. What is included? Which angle is included between DH and DF? Well, let's draw ourselves a picture. Okay, H, F, and D. All right. Which angle is included between DH? So put a tick on DH and DF. Okay. So what angle is included is asking for the sandwiched angle. So the sandwiched angle would be angle D. So the answer to this question is angle D is included between these two lines, between these two sets of tick marks. Number 12, okay, we got triangle OMR. So let's draw that out. OM, again, it doesn't matter the order of the letters when I name the triangle. Which side is included between angle M, I'll put an arc M, and angle R, I'll put double arcs R. Which side is included? Well, of course, that would be this side. Okay, I need a tick right there for it to be sandwiched, included in the middle. So in this case, I would say line segment MR or RM. Okay, 13, 14, 15, and 16 are all the triangle congruence postulate diagrams. That we've seen plenty of these. 13, we have this quadrilateral. Here we have a line. And all they give us is a tick there and a tick there. And it's saying, which of the theorems can I use to prove these triangles congruent? So let's list them out here. The first one we learned about was snake, SSS, side, side, side. And then we had an angle included between the sides, that's SAS. And then we had a side included between the angles, that's ASA. And then I had a side that wasn't included between the angles, that's AAS, where this guy is off to the side. Okay. Now remember, if you spell a cuss word forwards or backwards, ASS or ASSA, that is not one of them. Also, if you have three angles, AAA, that is not one of them. So if you don't have enough information, then you need to say NEI, not enough information. Okay. So number 13, the question I'm asking myself every time is, where can I add ticks or arcs to the diagram? Remember our little drum beat, ticks in the middle, ticks in the middle, ticks in the middle, ticks in the middle, little drum beat. So I can always add ticks in the middle. Okay, now where else can I add stuff? Well, I can add a 90-degree angle right there, can I? Can I add a box right there and a box right there? Yeah, there's some 90-degree angles. Nope. Remember, take your eyeballs and throw them in the trash can. It doesn't matter that that looks like a rectangle. Okay, that does not matter at all. Okay, in geometry, you can't go based on what it looks like. It certainly looks like that's a rectangle, but we don't know that. This angle right here could be 89 degrees. Well, that's not a right angle. Okay, so I don't know what those angles are. So I can't add anything else to my diagram. So I am dead in the water. I am stuck. There is not enough information to say those two triangles could be congruent. Okay, this could be a parallelogram or something. We don't really know. Okay, so not enough information. All right, number 14. We've got two triangles. And we have a box here and a box here. and I have a tick here and a tick here on the hypotenuse that says they're right triangles. All right, where can I add stuff to my diagram? I can't. Remember, the only time I can add stuff to my diagram are when the two triangles are touching each other. They're physically connected. They're sharing a line. This line is the same for both triangles. It ticks in the middle because it's the same. Arcs at vertical angles, but when they're separated, I can't add anything to my diagram. So once again, I am dead in the water. Not enough information. Number 15. We have this, and they give us ticks, double ticks, single tick, single tick. Can I add anything to my diagram? Yes, I can always add ticks in the middle for a line and arcs at vertical angles. Okay, so now I do have enough information to say these triangles are congruent. I've got a side, S, and I got arc in the middle, S, A, and then a single tick, S, A, S, and then I have double ticks, S, A, S. Okay, and let me go over this real quick because some of you guys are a little bit confused on this, trying to figure out how do I know which way to go. Okay, so if I've got X, Y, Z, and I have say say I have a single tick and say an arc and then a double arc. And sometimes students are like, I don't know, where do I start? How do I know which way to go? Clockwise, counterclockwise? Can I start here at the angle and go this way? Can I start here at the tick and go this way? And the answer is yes. You can choose. If I have A, S, A, I can choose to start at that A and go that way, or I can choose to start at that A and go that way. It won't matter. You'll still get angle side angle either way. But what you can't do, the way that I teach this, is wherever you start, if I start here or start here, you have to take the path that has the arcs and the ticks as close together as possible. Or another way to think about it is skip the fewest arcs and ticks. If I start right here at this tick, I can't go counterclockwise. I can't go that way. Because if I do that, I'm skipping a possible arc and I'm skipping a possible side. So I'm skipping an angle and a side. I'm skipping two things. But if I start at the tick here and go clockwise, then I'm not skipping anything here. I'm going from single tick straight to the arc. I'm only skipping one side, and then I'm going to the double arc. So I'm going tick, single arc, skip, double arc. But if I go this way, I'm going tick, skip, skip. Okay, I can't do that. But some of you are still confused. I don't know, can I start over here? And the answer is yes, I can start at the double arcs. And this would be angle, angle, side. Okay, so that would be A, A, S. But if I start over here, that's going to be side, angle, angle. It doesn't matter. SAA and AAS are the same thing. In fact, if you write SAA on the quiz, I'll still mark that correct. Now, typically we use AAS. That's the way we learned it. But SAA is the same as that thing. Okay, so I want to make sure you guys aren't confused on that. Okay, so here I've got double tick, single arc, single tick, double tick, single arc, single tick. SAS, SAS, SAS. Okay, number 16, the last one in the book. We have this going on. That. And they give us arc and tick, tick, and double arc, double arc. Okay, so once again, it doesn't matter where I start. I can start here. I can start at the single arc. If I do that, I can't go counterclockwise, because if I go to the left, I'm skipping a side and an angle. I can't do that. I've got to go this way. So I'm going to go angle, angle, and then the side. Okay, so that's AAS. Single arc, double arc, and then immediately to the single tick. If I start over here with a single arc, okay, I do have to go this way because I've got to go straight to the, if I go right on this triangle, I'm skipping a side and I'm skipping an angle. So for the triangle on the left, I have to go counterclockwise. I'm going single arc, double arc, single tick. Single arc, double arc, immediately to the single tick. So yes, these two triangles are congruent by AAS. Notice that this tick is not sandwiched in the middle. If this tick were over here, then in this case it would be not congruent because I'm going single arc, tick in the middle, double arc, single arc, double arc, and then the single tick. But if this tick were also over here, now I have the tick in the middle. I've got arc, tick, arc, tick, arc. In this case, that would actually be ASA. Okay. Okay, so those are the book problems. Now let's go ahead and jump into the other worksheets that we have and just continue going forward. All right, so I'm going to start here with the two triangles that look like a boomerang. And it says state if the triangles are congruent. If they are, state how you know. Okay, so I'm always asking myself, where can I add stuff to my diagram? Okay, ticks in the middle, always ticks in the middle. Okay, so I can add that there. Zoom out so I'll have issues with it focusing. All right, so tick in the middle. So I have double arc, single tick, single arc. On the triangle on the bottom, I have single arc, single tick, double arc. So that's A, S, A. So yes, those two triangles are congruent by A, S, A. Okay, so if we look at the next one here, number 2, okay, where can I add stuff to my diagram? Okay, always ticks in the middle. So I'll put a single tick here. And some of you guys were confused. How do I know whether to add a single tick or a double arc or triple? Just follow whatever they've given you. They haven't given us any ticks. So by default, I'm just going to start with 1. If they had already given me a single tick, then I would use a double tick. Okay, so just use logic and common sense there. Okay, so once again, I have angle, side, angle. And this 90-degree angle, this box here, 90 degree, that's just an arc. It's the same thing as an arc, just means angle. So this is also angle, side, angle. And then I have angle, side, angle. So that is also ASA. Okay, number 3 down here at the bottom. Where can I add stuff to my diagram? I've got a tick there and a tick there. I can always add arcs at vertical angles. Now they've already used a single arc, so of course I'm going to use a double arc. So double arcs at my vertical angles. Okay, so now once again, how do I know where to start? Well, we can start over here. This is side, angle, angle. Well, normally we do angle, angle, side. So I'll choose to start over here. Okay, and I can't go this way, because if I go this way, I'm skipping a side and an angle, so I need to go this way. So this is going to be angle, angle, side, AAS, and if I start at the double, I got to start over here. Now this one, I have to go this path, because if I go this way, I'm skipping 2 different things. I'm skipping a side and an angle. So if I go this way, I also have angle, angle, side, and notice this side, these 2 sides are not included in the middle. Okay, so this one I have angle, angle, and then a side. And this one I have angle, angle, and then a side. So yes, these 2 triangles are congruent by AAS. Okay. Now again, if this tick were over here, they wouldn't be congruent. If this tick were over here, they wouldn't be congruent. You've got to follow the same path. Everything has to line up in corresponding positions. Number 14, the first thing I'm thinking is the triangles aren't touching. Okay. If they're separated, I can't add jack squat unless they come out here to the side and literally tell me angle A is congruent to angle B or something like that. But shy of that, I can't add anything to this diagram. So I have tick, double tick, double tick, triple tick. Some of you guys are going to want to add a tick right there, but you can't do that, okay? Because remember, these 2 angles could be different. This angle can be 50 degrees, and this angle could be, well, it looks like 90. We don't know. This could be 95 degrees, and this could be 96 degrees. And that would mean that these third lengths aren't the same. Okay, so this is nothing, not enough information, dead in the water. Number 5, well, first thing I'm thinking is I see the X, I see the angles touching, so I'm going to put arcs in the middle. They've already used a single arc, so I'll use double arcs. Okay, so now I've got another thing that I think about. If this helps you, come out here to the side and list what you have. I've got one set of A's, I've got one set of matching angles, I have another set of matching angles, and then I have a set of double ticks, okay? So I have 2 angles and a side. So the only thing it could be is AAS, or it could be ASA. Those are the only 2 of the 4 that have 2 angles and an S, okay? So maybe if that helps you with the process of elimination. All right, so it's definitely not ASA, okay? Because I don't have a tick in the middle. This is not sandwiched in the middle, okay? So the question is it AAS? All right, let's start here at the single arc. Okay, so if I think it's AAS, I want to start with an angle. Okay, so start here. I've got to go this way because if I go this way, I'm skipping 2 things. So that's going to be angle, angle, single, double, double tick. So if I start up here, I go single, double arc, double tick. Yeah, so that works. AAS. So these 2 triangles are congruent by AAS. Number 6 is just like number 4. What can I add to my diagram? Jack squat. NEI, not enough information. Number 7, I have angle, 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 angle. They don't tell me anything about the sides. I can't add any tick marks anywhere. The triangles aren't touching. I'm dead in the water. This is angle, 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 but that's not one of them. Okay, remember, I can have one small triangle that has three the same angles, and I can have that same exact triangle with the same three angles but a different size, and those obviously would not be congruent triangles. So angle, angle, angle does not work. It's not one of our triangle congruence postulates. That means they're similar, but they're not congruent. Number 8, arcs in the middle. Double arcs there, double arcs there. Okay, so I'm looking for the tick. I've got two A's and an S, so it's either AAS or ASA. Now this tick is not in the middle. If it were sandwiched in the middle, then that might be an ASA. So I'm already thinking the only thing it can be is AAS. Well, let's see. I'm going single arc, double arc, immediately to the single tick. Single arc, double arc, immediately to the single tick. So yes, that is AAS. They are congruent. Okay, number 9. I got stuff being shared. The two triangles are touching, so ticks in the middle, ticks in the middle. Okay, so I've got arc, tick, double arc, tick, double arc. So that's ASA. Okay, number 10, ticks in the middle. Okay, so I have arc, box, immediately to the single tick, arc, box, immediately to the single tick. Now again, this side is not included. It's not between the arcs, so it's not ASA. This is AAS. Okay. All right, so let me go ahead and go on over to the second sheet that has the same stuff, and then we'll get to some of the ones on the back. All right, so I'm doing the first page of the other sheet here. I'm still stating whether or not I can use SSS or SAS, all that kind of stuff. State if the two triangles are congruent. Okay, so number 1 here, can I add anything to my diagram? And the answer is yes, I can add ticks in the middle. Okay, they've already used double tick, so I'm going to use a single tick. If they had used single tick, of course I'd use a double tick. Okay, so now I have single tick, box, double tick. So I have side, angle, side, and I also over here have side, angle, side. So yes, these triangles are congruent by SAS. Okay, where can I add? They've already used a single tick, so I'll go double tick. Okay, ticks in the middle. All right, so this triangle up top, I have single tick, single arc, double tick, with the arc being sandwiched in between the ticks. Wait a minute, over here though, I have single tick, double tick, and then the single arc. This arc is sandwiched in the middle, but this arc is not. This arc, for it to be congruent by side, angle, side, this arc would need to be over here. Okay, I would need this guy to be over here, but it's not. So the arcs aren't in the same corresponding position, so this is NEI, not enough information. Number 3, ticks in the middle. All right, this is the easy one. So I've got side, angle, side, side, and then single, single, double, side, angle, side, SAS. Okay, so this one, the triangles aren't touching, so I can't add anything. The first thing I notice is that this arc is sandwiched in the middle. That's the included angle right in the middle, but this arc is not sandwiched in the middle. This arc would need to be up here, so that it's right smack dab in the middle of these two, and it's not. So this is another NEI, not enough information. 5, that's easy, ticks in the middle, triple ticks, so I have side, side, side. Okay, number 6, same thing, single tick in the middle, 3 sets of ticks, side, side, side. This one here, single, single, double, double, triple, triple, side, side, side. Over here, ticks in the middle, put double ticks in the middle. So I've got single tick, single arc, double tick, side, angle, side, and then side, angle, side. SSS and SAS are by far easier than the other two that we just did. Number 9, ticks in the middle. Okay, so I've got single tick, single arc, double tick, and then I have single tick, double tick, and then the single arc. Okay, so again, these arcs aren't in the same spot. This arc is included between the ticks, but this arc is not included. This arc needs to be up here, and it's not. So that's another NEI, not enough information. Well, this is easy. Double tick, box, triple tick, double tick, drop, box, triple tick, SAS, side, angle, side. Okay, so let's take this sheet that I just got through working on. Let's turn this one over to the back. So we have, on the back of these sheets, they're asking what other information do I need to be able to use the triangle congruence postulate that they're giving us. Okay, so they want us to use SAS. Okay, so that means I've got to figure out what other information do I need. Well, I can always add vertical angles and ticks in the middle, so let me add those. Okay, so vertical angles there. Now, for me to use SAS, I've got a tick, arc. I need another tick. I need another S, and the angle's got to be in the middle. So if this guy is sandwiched in the middle, I need to be able to put double ticks there and double ticks there. Okay, so that means I need to be able to say that line segment JI is congruent to line segment IE. Okay, if you tell me, if you give me that information that allows me to put these double ticks there, I can say, oh, okay, now that means I can use SAS. All right, for these two, SAS, the A's got to be sandwiched in the middle. It's got to be in the included angle. So that means I need to be able to put an arc there and an arc there. Okay, so I would need to know that angle L is congruent to angle H. So I can put those arcs there. SSS, okay, well, I can always put ticks in the middle. So somebody needs to tell me that ZY, triple ticks, and DX are the same. DX needs to be congruent to ZY, and then I can say, I can put my ticks there. Okay, here I need a tick there and a tick there, so I need to know that RT is congruent to ZX. Okay, number 15, SAS. Okay, A has got to be in the middle. So here's my A. That's got to be sandwiched in between a tick and a tick. So I need a double tick, so it's right in the middle. I need a double tick there, tick, arc, tick, and I need a double tick there. So I would need to know that WU is congruent to ZX or XZ. Side, side, side. I need a tick there and a tick there. I need to know that GE is congruent to WY. That's easy. Okay, number 17. I can always put ticks in the middle. I don't need to know that. Somebody doesn't need to tell me that because I know that there's a tick in the middle. I know that GF is shared between both triangles. But I do need somebody to tell me that there are triple ticks on EG and triple ticks on GQ. So EG is congruent to GQ. I need to know that information. Okay, SAS, the A's got to be in the middle. Okay, so I can always add arcs at the vertical angles. I don't need to know that. I already know that. But to use SAS, this guy's got to be in the middle. So I've got to go double tick, single arc. I need a single tick here. Double tick, single arc. I need a single tick here so that this A is sandwiched in the middle. So somebody needs to tell me that DS is the same length as ST. Now remember, these are line segments. I mean, that could be lengths. If somebody told me this is 3 millimeters and this is 3 millimeters, they're the same length, I can say, okay, I can put a tick there, they're the same length. Okay, last one, home stretch. So let's go back over to the back of the first page that we're working on. So this is the other boomerang problem, and we're stating what other information do I need to be able to use ASA. Okay, so I've got an arc here, so I can always put ticks in the middle. And then now the question is to use ASA. Now that S has got to be sandwiched in between the angles. So I've got to go angle, tick, angle. So I would need to know, somebody would need to tell me that I can put a double arc there and a double arc there. Somebody needs to tell me, now here I can't say angle C, I need a 3-letter method. Somebody needs to tell me that QCD, angle QCD, is the exact same as angle ECD. And then I can use ASA. Okay, make sure y'all got that. All right, ASA, once again, the S has to be sandwiched in the middle. So I need a tick on KL, and I need a tick on TU. KL, I would need to know that KL is the same length as UT. ASA, here's a box. I've got arcs in the middle. The side has to be sandwiched in the middle, so I need a tick between C and S, and I need a tick between S and R. So somebody needs to tell me that CS is the same length as SR, that they're congruent. Okay, next one. Vertical angles. They've already used a single arc, so I'll use a double arc. Okay, now the S is in the middle. It's got to be sandwiched, so I need a tick on WV and I need a tick on VK. So I need to know that VW is congruent to VK. Okay, last few, AAS. Number 15, ticks in the middle. Okay, now here's a little bit more complicated with the AAS, a little bit trickier. You got to figure out, do I need to be able to put arcs at E and T, or do I need to put arcs here at this angle C? Well, if I put arcs here, if you tell me that ECD, if I put an arc right there, that means the tick is in the middle. That would be ASA. That's not what I want. I want AAS. I don't want this side to be in the middle. So that means I need to be able to put an arc at E, a single arc at E, and a single arc at T. That way this tick is not in the middle. That way I have angle, angle, side, angle, angle, side. All right, so somebody needs to tell me the angle E is congruent to angle T, and then I can use AAS. Okay, AAS, or number 16. Now this one actually has two different answers. The tick does not need to be in the middle, so it can't be YX. So if I put, let's say I choose to put a tick here. So I'll go triple, double, single tick. Over here I got to go triple, double, single tick. So somebody needs to tell me that ZX is congruent to NL. Okay, that's one possible option. Or let's say I don't put the ticks there. Let's say I put the tick over here and I go double, triple, single. Then over here I could go double, triple, single. I could also put a tick here. If somebody told me that YZ was congruent to NM, then I could also use AAS, AAS. So this one actually has two answers. What I can't do is put a tick between the triple and the nothing, and then put a tick over here between, right here, and put a tick between the double and the nothing. Those would not be congruent. All right, last two. ASA, ticks in the middle. I need this tick to be sandwiched between the angles. This guy's got to be in the middle, so that means I need double arcs here and double arcs here to be able to use angle, side, angle, angle, side, angle. So somebody needs to tell me the angle IGH, this angle right here, is congruent to angle VHG. Okay, VHG. I need to know that there are double arcs there and double arcs there. So angle IGH congruent to angle VHG. All right, last one. AAS, ticks in the middle. All right, so again, this S is not sandwiched in between the two angles. So once again, I've got a couple of different things that I could do. I could put double arcs over here so that I'm going single, double immediately to the tick. And that means I could go single, double immediately to the tick. So I would need somebody to tell me that angle FKL is congruent to angle JLK. Sorry, you can't see that. FKL is congruent to JLK. So I have double and double arcs. That works. Or somebody else could also tell me that these two angles are the same. I could put triple arcs here. That way I could go AAS and AAS. So also, I could say if somebody told me the angle JKL were congruent to angle FLK. Both of those would also work. Alright, that's it for this video. Hope you guys enjoyed it, and I wish you good luck on the quiz. We'll see you on the next video.